I would say probably less than $20,000 would be my guess.
Okay.
Tesla is turning the game into its own by integrating solid-state batteries into Optimus, a move that slashes production costs by up to 70%. With solid-state battery prices now as low as $50 per kilowatt-hour, mass-producing humanoid robots at record-low costs is finally within reach. Tesla is rapidly advancing toward its goal of dominating the $10 trillion robot market. So how will the Gen 3 Tesla bot lead the industry with this breakthrough battery technology? Before we begin, please help us reach 4,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot Gen 3, Tesla EVs, and the latest news. Why is solid-state battery the ideal choice for Tesla Optimus Gen 3? Compared to electric vehicles, humanoid robots have far stricter requirements for battery weight, size, and safety. According to official data we've collected, Optimus currently uses a battery pack with a capacity of around 2.3 kilowatt-hours, allowing for approximately 8 hours of continuous operation. However, to scale production to millions of units, Tesla must overcome 3 major challenges. The current 4,680 lithium-ion battery is too heavy, around 8 to 12 kilograms. The charging and operating time is still insufficient, and there is a fire risk when the robot operates in various dynamic postures. These are precisely the issues that solid-state batteries, known for being lighter, having higher energy density, and offering superior fire resistance, are capable of solving. Solid-state batteries replace the traditional liquid electrolyte with a solid one, boosting energy density to 400 to 500 watt-hours per kilogram compared to 270 watt-hours per kilogram in 4680 batteries, while nearly eliminating the risk of fire. Furthermore, they allow for much faster charging, potentially under 15 minutes, and have a lifespan 2 to 3 times longer than conventional lithium-ion batteries. Under ideal conditions, a solid-state battery could help reduce Optimus's total weight from 55 kilograms to under 50 kilograms, while extending its continuous operation time to up to 12 hours, a significant advantage for robots working in factories or assisting humans in daily environments. Signs that Tesla is seriously pursuing this path are becoming increasingly evident. In 2022, Tesla filed a patent related to lithium metal batteries using nanocoatings to stabilize solid electrolytes, aiming to improve durability and reduce short-circuit risks. In 2023, Tesla also recruited several engineers from top solid-state battery companies like Solid Power and QuantumScape. Notably, Elon Musk has repeatedly emphasized, "We will do everything to reduce weight and increase the performance of the robot. Battery optimization is mandatory." These statements, combined with Tesla's vertically integrated manufacturing strategy, suggest that the company may develop and apply solid-state batteries in upcoming Optimus Gen 3 or Gen 4 prototypes. If successful, this would represent a revolutionary leap forward. Optimus could operate longer, become lighter, and far safer. A lighter robot would result in more agile actuators, improving mobility, heavy lifting, and task precision. Higher energy density would also allow Tesla to design a more compact battery pack, freeing up internal space for more sensors or advanced processors. Equally important, robots with shorter charging times and longer battery life would become extremely economically viable when deployed at scale in manufacturing environments. However, the road to mass-market solid-state batteries is far from easy. Currently, solid-state batteries remain expensive, costing between $200 to $300 per kilowatt-hour, roughly 4 to 5 times more than Tesla's in-house 4680 lithium-ion cells, which are around $60 per kilowatt-hour. Scaling up production is also a major hurdle. Even industry leaders like Toyota, Solid Power, and QuantumScape are still in the experimental phase, without stable commercial production lines. Additionally, the manufacturing defect rate for solid-state batteries remains high due to their sensitivity to temperature, humidity, and the complex microstructure of their materials. With its advantage of full control over the supply chain and manufacturing, Tesla could become the first company to commercialize solid-state batteries for humanoid robots, especially if the rollout begins in small batches and gradually scales up. The most realistic scenario is that Tesla will test solid-state batteries in premium Optimus Gen 3 versions between 2025 and 2026, before applying them widely in Generation 4. If Elon Musk and his team can overcome the cost and mass production challenges, a solid-state-powered Optimus will not just represent a technological leap, but could usher in a new era for humanoid robots where they become lighter, smarter, and as common as electric vehicles are today. As tech giants around the world race to develop humanoid robots, battery technology could become Tesla's strategic weapon for market dominance. Rivals like Figure AI or Agility Robotics still rely on conventional lithium-ion batteries and lack Tesla's deep in-house battery development or supply chain control. Even Xiaomi's Cyber One, which leans heavily on expressive interactions, has not shown any progress in solid-state battery development. This puts Tesla in a prime position to commercialize solid-state batteries in humanoid robots, enabling it not only to surpass U.S. startups, but also to erect technological barriers against Chinese and Japanese competitors. If Tesla succeeds in integrating solid-state batteries into Optimus at a reasonable cost, the impact will go far beyond technical performance. Operational costs will drop significantly, thanks to battery lifespans that could stretch across decades, minimal maintenance, and ultra-fast charging that maximizes uptime. Once the monthly rental cost for a robot falls below $1,000, Optimus could become an appealing solution not only for factories, but also for service providers, logistics firms, and even households. As global labor shortages and rising wages continue, a robot that is lighter, more durable, safer, and cheaper to operate than a human could become a disruptive force in today's labor market structure. As you know, Tesla's success in robotics cannot be separated from Elon Musk's radical design philosophy, one that relentlessly pursues absolute simplicity. Musk once said,
The best part is no part. The best process is no process. It weighs nothing, costs nothing, can't go wrong.
This principle is embedded in every Tesla product, from eliminating the gear shifter in the Model S to integrating the battery into the vehicle's chassis. For Optimus, Elon is pursuing a design that can be mass-produced like a car, meaning every gram of weight and every material detail must be optimized. Solid-state batteries, with their compact, lightweight, and safe characteristics, are the next inevitable step toward realizing the goal of producing millions of robots per year in the most efficient and streamlined way. However, if the plan to adopt solid-state batteries fails, Tesla could face serious setbacks. The robot's weight may remain too high, limiting agility, especially for tasks like lifting, stair climbing, or working in tight spaces. Worse still, if a startup or major company like Toyota, Honda, or a Chinese firm gets there first with commercialized solid-state batteries, Tesla could lose its leadership position, something Elon Musk has repeatedly warned is unacceptable for the company's long-term strategy. In the long term, if Tesla succeeds with solid-state batteries, it could pave the way for even more advanced generations like lithium-sulfur batteries, or even self-adaptive battery systems that adjust energy output based on the robot's activity. With the massive amounts of real-world data Optimus collects, Tesla could train AI not only to operate robots efficiently, but also to optimize energy usage contextually, something no traditional battery company has ever attempted. This would be a revolutionary advantage, transforming Tesla robots from mechanical machines into intelligent, adaptive systems that can respond seamlessly to real-world conditions. Once again, please help us reach 4,500 subscribers. This is important for us to stay motivated. Thank you. What advantages would Tesla gain by mastering solid-state batteries for Optimus? In our assessment, if Tesla masters solid-state battery technology, it will be the key to significantly elevating Optimus. First, it would greatly reduce the robot's weight while improving its overall performance. Solid-state batteries are not only lighter, but also offer a higher energy density compared to traditional lithium-ion batteries. According to research, solid-state batteries can deliver twice the energy within the same volume. For a humanoid robot like Optimus, this means a lighter body, more agile movement, and improved energy efficiency. A lighter robot will be able to move more easily, perform complex tasks, and reduce the load on motors and mechanical components. A simple example can be seen in electric vehicles. Tesla has leveraged battery technology to reduce vehicle weight and optimize performance across its models. The Model S, with its minimalist design and battery pack integrated beneath the floor, helps lower overall weight, thereby improving driving range and acceleration. Similarly, Optimus could operate more efficiently if solid-state batteries help cut its weight by 20 to 30%, similar to how modern EVs reduce mass to achieve better performance. A lighter robot not only moves faster, but can also operate continuously for several hours without needing to recharge. Second, the extended battery lifespan will significantly reduce long-term operating costs. One of the biggest advantages of solid-state batteries is their ability to withstand up to 10,000 charge cycles, 3 times more than traditional lithium-ion cells. This not only extends the robot's service life, but also lowers maintenance and battery replacement costs throughout its lifespan. If Optimus is equipped with solid-state batteries, the reduced maintenance requirements will enable Tesla to offer robot services at lower operating costs. Take electric vehicles again as an example. Tesla has reduced maintenance costs by optimizing battery performance. The Model 3 can operate for 500,000 to 1 million miles without major battery issues, thanks to Tesla's advanced battery technologies. If Tesla applies the same level of innovation to Optimus, the company could substantially lower robot maintenance costs, making the product more attractive for long-term leasing by businesses. Reducing maintenance and battery replacement expenses over the robot's lifetime could drive rental prices below $1,000 per month, a much more accessible level compared to competitors like Honda or Toyota, who still face high production costs for humanoid robots. Third, supply chain control and lower production costs. Tesla has built an exceptionally strong and independent battery supply chain, covering everything from lithium mining to cell manufacturing and energy management system optimization. This allows Tesla to avoid reliance on external suppliers like CATL, Panasonic, or LG Energy, increasing production flexibility and reducing supply chain risks. If Tesla masters solid-state battery technology, it can manufacture these batteries within its own factory network, reducing production costs and accelerating product rollout. In the EV industry, Tesla has already demonstrated the benefits of controlling the battery supply chain, allowing the company to lower costs and offer competitively priced electric vehicles like the Model 3. Tesla has outpaced rivals such as Rivian and Lucid Motors by producing EVs more cost-effectively thanks to its in-house battery production. Likewise, controlling solid-state battery technology for Optimus could bring the production cost of each robot down to around $20,000, enabling Tesla to produce millions of humanoid robots at lower prices and with a strong competitive edge. Fourth, deep integration with robot design for space and performance optimization. Solid-state batteries can be integrated directly into the robot's frame, similar to how Tesla embeds battery packs into the floor structure of its EVs. With a minimalist design approach, Tesla can save space for other critical components, such as motors and control systems. This not only enhances structural rigidity, but also improves mechanical performance, enabling the robot to move faster and more nimbly in tasks requiring precision and agility. Tesla has already applied this design philosophy in EVs, especially in the Model S and Cybertruck, where the battery is placed beneath the vehicle floor to maximize space, improve performance, and enhance durability. Applying the same principle to Optimus would make the robot more efficient, energy-saving, and better optimized for complex robotic features. Finally, Tesla holds a major advantage in data and AI for energy optimization. One of the most significant benefits Tesla can leverage if it masters solid-state batteries for Optimus is the ability to collect and analyze data from millions of robots. Deploying robots with the same battery type at scale opens the door to real-time energy optimization using AI. Tesla can learn from how robots operate in different environments and use that data to extend battery life and minimize energy waste. Tesla already uses AI software to optimize energy usage and range in its vehicles. With technologies like autopilot, Tesla analyzes data from millions of cars to improve performance and enhance the driving experience. Similarly, if Tesla applies AI to manage energy use in Optimus, it will be able to improve each robot's operational efficiency, reduce energy costs, and enhance overall productivity.
really the kind of thing where you could tell it to do kind of a wide range of tasks, including tasks where it has not specifically done that exact thing before.
Elon Musk emphasized that the robot not only moves more smoothly by over 20%, but is now ready to enter real-world use through a rental model. Starting at just $2.50 per hour, Tesla has transformed Optimus from a luxury item into a smart labor tool, officially prepared to serve households and businesses as early as 2025. How will Tesla reshape the global labor market with this bold rental strategy? Before we begin, please help us reach 4,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot Gen 3, Tesla EVs, and the latest news. How does Tesla plan to offer Optimus for rent? Instead of simply selling the humanoid Optimus robot at a high price estimated around $20,000 per unit, Tesla is likely to implement a flexible rental service model, similar to how Uber operates with cars. This model is known as Optimus as a Service, renting the robot as a service by the hour, day, shift, or monthly contract. So how would Tesla offer Optimus Gen 3 rentals tailored to different customer segments? Tesla could divide its rental offerings into three main groups: individuals and households, small businesses, and large enterprises. Each group would have a rental method suited to their needs. For individuals and households, Tesla would offer Optimus robot rentals by the hour or by the day, with flexible pricing ranging from $15 to $25 per hour. Rental sessions typically last 2 to 3 hours. Users simply open the Tesla app, select the time and task, such as house cleaning, elder care, unloading groceries, or assisting people with disabilities. Optimus will be dispatched to the specified location and time, complete the task, and return to the operations center. With this model, users can experience intelligent AI robotics in daily life without making a large purchase, while enjoying guaranteed quality, safety, and efficiency. This is an ideal solution for busy individuals who don't want long-term commitments but still need help with specific tasks. For small and medium-sized businesses, Tesla may offer robot rentals at rates between $100 and $150 per day, depending on the number of working hours and the nature of the tasks required. Rental options would include shifts, 4 to 8 hours, or full-day service for retail shops, restaurants, hotels, or small offices. Robots can perform tasks such as cleaning, customer greeting, carrying items, inventory checking, or working reception desks. This model significantly reduces part-time labor costs while increasing automation without the need for complex technical infrastructure. Since robots don't take lunch breaks, don't require insurance, and can operate continuously with high precision, operational efficiency will surpass traditional human labor. For large enterprises, rental rates range from $2,000 to $3,000 per month per robot, with full maintenance and technical support included. This is the optimal choice for factories, hospitals, and shopping centers, where robots can replace a wide range of tasks, from assembly lines to customer service. Long-term rentals not only reduce the cost of recruitment, training, insurance, and employee benefits, but also offer flexibility when workloads vary due to seasonal changes or business demands. This pricing is very reasonable compared to the total cost of a full-time employee and allows companies to adjust their workforce without the complications of hiring and firing. For personal users, renting Optimus offers convenience, flexibility, and cost savings. They don't need to spend $20,000 to own a robot, don't have to worry about maintenance or software updates, and only pay for completed tasks. With fast-learning AI and adaptive capabilities, Optimus could become a versatile personal assistant for every household. For small businesses, Optimus helps address the shortage of low-skilled labor, especially in developed countries like the US, Japan, and Germany. It also helps maintain consistent performance, minimize operational errors, and eliminate recruitment, training, and social welfare costs. Large enterprises will benefit the most, as large-scale rentals bring economic efficiencies and allow functional customization for different production environments. Tesla may also offer rental packages with on-site technicians or scheduled maintenance support, giving businesses peace of mind for long-term deployment. Once again, please help us reach 4,500 subscribers. This is important for us to stay motivated. Thank you. How does leasing Optimus benefit Tesla? When considering the Optimus rental model, Elon Musk's long-term vision and extremely smart strategy are clearly evident. Instead of selling each robot for around $20,000, Musk is steering Tesla toward a recurring revenue model, where the company retains ownership and rents out the robots by the hour, day, or through service packages. With production costs under $10,000 per unit and expected rental rates of $20 to $30 per hour, Tesla could recover its investment within 4 to 6 months, after which nearly all revenue becomes profit. Not selling the robots outright allows Tesla to maintain full control over software and user data, similar to how Musk previously implemented the FSD full self-driving system. Through the rental model, Tesla will collect billions of hours of real-world interaction data, a priceless resource for training AI, improving hardware, and continuously updating software over the air. Musk has repeatedly emphasized that AI truly becomes intelligent only when it learns from real-world environments, and this is the shortest path to achieving that. For users, the rental model opens up the opportunity to access cutting-edge technology without the need for a large investment. They can use the robot flexibly based on their needs, from household assistance and elderly care to industrial tasks. Businesses can rent by the shift, while households only pay by the hour without having to worry about maintenance, obsolescence, or operational training, as Tesla takes care of everything. Tesla's superior strength lies not only in its robot technology, but also in its ability to scale due to its existing ecosystem of manufacturing, software, and AI. While competitors like Figure AI, Agility Robotics, Sanctuary AI, Apptronic, and Boston Dynamics are still struggling with commercialization models, Tesla is ready to turn robots into a global utility service similar to Uber or Airbnb, but for working robots. For example, Agility Robotics' Digit Robot has been tested at Amazon, but mostly in a limited environment and has not yet reached the general consumer. Boston Dynamics, while outstanding in engineering, still focuses on technological demonstrations. Sanctuary AI is focused on simulating human intelligence in a lab, and Apptronic aims at versatile robots but lacks large-scale deployment capabilities. If Optimus can indeed perform tasks such as cleaning, transporting goods, elderly care, or medical assistance, Tesla will not only lead the humanoid robot market, but also usher in a new era of personal workforce automation. How will Tesla handle it if the Optimus robot encounters a malfunction during a rental? If the Optimus robot encounters a malfunction during a rental, we believe that Tesla will leverage its proven strategies to quickly resolve the issue while maintaining high levels of customer satisfaction. With Tesla's expertise in over-the-air (OTA) software updates, which are deployed more than 100 times annually for its electric vehicles, this feature will be an integral part of the Optimus robot. These updates allow Tesla to remotely diagnose and resolve software issues in real time. By collecting diagnostic data from the robot, Tesla can push software fixes or optimizations directly to the robot, minimizing downtime and ensuring that the robot continues to operate at optimal performance. This remote troubleshooting method has proven effective with Tesla's electric vehicles, which rely on similar OTA technology to resolve issues without requiring customers to visit a service center. In the case of a hardware malfunction, we believe that Tesla will use its extensive global service network, which includes over 2,000 service centers as of 2024, to handle repairs or replacements. Tesla's network, supported by a workforce trained to handle both hardware and software issues, will ensure that the problems are addressed efficiently and with minimal disruption to the rental service. If a robot is found to be irreparable during the rental period, Tesla could provide a replacement unit, similar to how the company offers loaner vehicles when customers' cars need extensive service. This approach minimizes downtime for customers, allowing them to continue using the robot without significant delays. We also believe that this will ensure high levels of customer satisfaction, further strengthening Tesla's reputation for customer-centric service. Elon Musk has often emphasized that Tesla's data-driven approach enables rapid improvements in both hardware and software. We foresee that the data collected from Optimus robots, including performance metrics and malfunctions, will be invaluable in optimizing future versions of the robot. Just as Tesla uses data from its vehicles to improve the FSD system, Optimus robots will benefit from continuous data feedback to fine-tune their AI and improve reliability. This data-driven improvement strategy has already resulted in significant performance gains in Tesla's vehicles and is likely to extend to the robot lineup as well. The rental model also presents significant cost-saving advantages for Tesla. By minimizing downtime through OTA, updates, and efficient repair processes, Tesla ensures that the rental periods remain as profitable as possible. Moreover, Tesla can achieve economies of scale as the rental fleet grows, reducing the per-unit cost of maintenance and repairs. For example, Tesla has reduced the cost of producing its electric vehicles by 30% over the past decade, and a similar cost reduction could be achieved in the Optimus robot rental model over time. The efficiencies gained will allow Tesla to offer competitive pricing, making it accessible for small businesses and households while maintaining healthy profit margins. Why must you know this before bringing a Tesla bot home? Despite facing market pressures, Tesla's AI and robotics strategy continues to inspire confidence among analysts and investors. Morgan Stanley's unwavering faith in Tesla's technological future, particularly in the realm of AI and robotics, is exemplified by their maintained overweight rating on TSLA stock. A leading analyst at Morgan Stanley emphasizes the transformative impact of humanoid robots on key economic indicators that humanoid robots could reshape production and how an economy is defined, and predicts factory-made robotic labor could tweak GDP markers like dependency ratios, retirement age, and GDP per capita. This perspective underscores the far-reaching implications of Tesla's robotics initiatives, extending well beyond traditional automotive manufacturing. The bank's steadfast support, despite a decline in vehicle deliveries, highlights the perceived value of Tesla's AI and robotics ventures. Morgan Stanley suggests that Optimus could potentially disrupt 30% of global labor, representing a staggering $30 trillion opportunity. This projection indicates the enormous market potential that investors see in Tesla's robotics initiatives. To support this confidence, Tesla has recently filed patents related to robot dexterity and autonomous learning systems, demonstrating its commitment to pushing the boundaries of robotics. Moreover, the company's Dojo supercomputer, specifically designed to train neural networks for self-driving and robotic applications, gives Tesla a unique infrastructure advantage in accelerating AI development. Market observers view these moves as signals of a long-term play that could unlock new economic value far beyond the automotive sector. As traditional manufacturers struggle to pivot toward AI, Tesla's early investments and bold vision are seen not as speculation, but as strategy. Recently, Tesla's aggressive recruitment campaign for its humanoid robot project, Optimus, has marked a pivotal shift in the company's strategic priorities, signaling a transition from conceptual development to full-scale production. With over 80 job openings listed across the United States as of April 2025, this initiative underscores Tesla's commitment to positioning Optimus as a cornerstone of its future technology portfolio. This report examines the scope of Tesla's hiring efforts, the technical and operational implications of the roles being filled, and the broader impact of advancements in the humanoid robotics sector. When people think of humanoid robots, the image that usually comes to mind is something straight out of a sci-fi movie, a futuristic fantasy still far removed from reality. But not for Elon Musk. For him, building a smart robot isn't the end goal, it's just the beginning. What he really wants is to bring them out of the lab and into mass production. One of the key reasons humanoid robots haven't gone mainstream yet is simple. They haven't been useful enough to justify the cost, and manufacturing them at scale is an enormous technical hurdle. Tesla believes it can change that narrative. The company isn't just dreaming about millions of Optimus units in the distant future. It's actively aiming to produce 5,000 units this year alone. That's not a distant ambition. It's a target for 2025. Musk has even floated a higher number, producing enough parts for up to 10,000 or even 12,000 robots by year's end. Still, he's realistic. As he puts it, if they manage to complete half of that, around 5,000 fully assembled Optimus units, it would already be a major win, given that this is an entirely new category of product with no existing roadmap to follow. Unlike scaling electric vehicle production, which Tesla has already mastered, mass-producing humanoid robots is a different beast altogether. These machines demand extreme mechanical precision, longer testing cycles, and tighter system integration across hardware and AI. For the first time, a purely general-purpose AI solution for full self-driving will soon become a reality, requiring only cameras, the Tesla AI chip, and Tesla AI software. Elon Musk recently expressed confidence in this entirely different approach from anything else on the market. However, the growing customer demand for a humanoid robot with comprehensive capabilities for healthcare applications is expected to push Tesla to accelerate robot production and introduce 2 new variants of the Tesla bot. These will be equipped with entirely new technologies that Elon Musk has never previously revealed. So, what are these breakthrough technologies that are about to be unveiled? That's exactly what we'll be diving into in today's episode. And if you're thinking about owning a Tesla humanoid robot by early 2026 and want to stay updated with all the latest tech, don't forget to hit that subscribe button and turn on notifications by ringing that bell for the newest updates. If we've ever discussed why Tesla chose not to use LiDAR in combination with a camera system for Tesla Optimus, some believe the decision stems from LiDAR's relatively large size and increasingly high costs. However, the tech world never stands still, and some suppliers now have the capability to produce an entirely new kind of LiDAR device, weighing and measuring as little as 7 millimeters. These compact sensors, developed by RoboSense, can be integrated into robots and manufactured at a cost of just $499. Back to Tesla Optimus, as shown in the recent video navigating rough terrain, the robot demonstrates impressive flexibility and balance control, even when going uphill or downhill. What's most fascinating is that Milan Kovac, Vice President of Engineering for Optimus, explained exactly what it took to get Optimus to this point. The robot is genuinely progressing in its ability to walk and can maintain balance on uneven ground, even while walking blind. Tesla has achieved this using only sensors, all powered by a neural network running on embedded computing hardware. And here's the key question: what kind of sensors did Tesla use that allowed the robot, without a traditional camera setup, to accomplish this? The answer could very well be LiDAR, one of the technologies Elon Musk himself once deemed unnecessary for Tesla products. Essentially, Tesla is building Optimus from the ground up, relying on as much supplemental data as possible during vision training. This is similar to how they train FSD on vehicles by using LiDAR rigs to validate the accuracy of their vision system. This approach proves that Tesla does in fact see value in compact LiDAR sensors for Tesla Optimus. The LiDAR sensor we are referring to is not a traditional rotating mechanical type. It is a fully solid-state LiDAR, equipped with an ultra-wide 120 by 90 degree field of view. It combines high performance, a compact design, and automotive-grade reliability. This enhances the robot's ability to detect object sizes, contours, and distances in real time, making it highly capable in tasks like obstacle avoidance, mapping, and navigation. This technology promises to provide comprehensive and precise environmental awareness, essential for advanced autonomous navigation and decision-making. With a maximum detection range of up to 75 meters, 7 times that of conventional depth cameras, it represents a significant leap in robotic perception. Building a realistic surrounding environment becomes more achievable with over 260,000 points per second and 144 neatly structured beams. This allows for precise detection of both static and dynamic small obstacles. It excels in efficient 3D mapping, accurately reconstructing environments such as roads, yards, homes, warehouses, and ports. To better illustrate the effectiveness of LiDAR technology, we would need a comparison test between Tesla's camera-only autonomous driving system and a LiDAR-based system, such as one powered by Luminar. The experiment would evaluate how vehicles react when encountering a child on the road under 6 different scenarios. standing still, suddenly running onto the street, in fog, in rain, under bright light, and standing behind a wall. Test results showed that LiDAR generally performed better, mainly due to its superior performance in foggy and rainy conditions. There are also some notable drawbacks to vision-only technology. For example, it can struggle when facing bright lights, and Tesla has previously encountered issues with vehicles failing to detect trucks crossing the road, leading to accidents, or confusing overpasses with signs or the sky. Both of these problems can be addressed by cross-referencing data from multiple sensor types. Relying solely on vision would limit Optimus's working environment and prevent it from performing tasks in conditions involving fog, mud, or dust. What significant update on Tesla Optimus's vision? All right, it seems that everyone knows Tesla Optimus is equipped with a set of 8 sensor cameras, but perhaps you've overlooked how these camera systems actually work. Remember, Optimus runs on the same overall AI stack as FSD. In fact, Optimus uses the FSD computer and a branch of the FSD stack for vision-based tasks. The camera array builds a 3D model of the environment with accuracy nearly equivalent to the human eye. Then, the hardware component processes the images captured by the cameras in real time, with a latency of just 0.2 seconds. That represents a significant leap forward in technology. According to our research, a new 4-camera cluster technology has been developed, integrating multiple sensors to provide a hardware-level fusion of depth information, image data, and motion posture data, all synchronized in both time and space. This enables the robot to capture comprehensive details about its environment, overcome interference from sunlight and highly reflective surfaces, and adapt to a wide range of indoor and outdoor scenarios. With a maximum range of up to 70 meters, 6 times greater than that of conventional 3D cameras, this distance is well suited for a robot designed for indoor tasks, like Tesla Optimus. It breaks the limitations of traditional cameras, delivering superior performance to fully meet the demands of intelligent robots in obstacle avoidance, both indoors and outdoors, as well as in mapping and hand-eye coordination. This significantly enhances both efficiency and safety. Tesla has shown what the robot sees, and it looks very familiar. That's because the neural networks are being pulled directly from autopilot. However, training data must be collected specifically to represent indoor environments and other objects not typically encountered in vehicles. Engineers have trained the neural networks to identify high-frequency features and key points in the robot's camera feed, such as the charging station. Tesla has also utilized the autopilot simulator, but adapted it for use with the robot programming system. Optimus's torso houses a centralized computer, which Tesla says is designed to handle everything the human brain does, such as processing visual data, making split-second decisions based on multisensory input, and facilitating communication. In addition, the robot is equipped with wireless connectivity and audio support. The reliance on AI and machine learning algorithms enables Optimus to master the automation of a wide range of tasks. This is because it can adapt based on the context of its environment. In addition, Optimus is equipped with an intuitive navigation system powered by an end-to-end neural network for movement. It has been trained on a library of natural motion references, such as taking a box off a shelf, lifting an object and placing it on a surface, taking medicine out of a container, watering plants, and pouring water. Optimus's fully trained neural network has also been shown to autonomously classify objects by color, continuously learning in the process. Tesla Optimus is often compared to Boston Dynamics' Atlas. While Optimus is designed using aluminum and plastic, Atlas incorporates steel, aluminum, and 3D printed components. It is heavier by comparison and built to operate in more challenging environments, such as construction sites and in search and rescue missions. However, more humanoid robotics technologies are now entering the market, including Figure AI, Unitree, and several other models emerging from the Chinese market, all of which are beginning to draw comparisons with Optimus. And when can you buy a Tesla Optimus? With the disclosed production cost of $15,000 per Tesla Optimus unit, Tesla may go beyond its initial plans, such as offering rentals at $40 per day or selling them at a higher price to optimize profits, potentially not at the previously stated $20,000. However, shortly after things run smoothly, that is, once Tesla can mass-produce the robots, they will focus on bringing this first lineup into production. It could turn into an assembly line. If they manage to produce between 5,000 to 10,000 bots in 2025, that would be their current target, ramping up the supply chain. Once they exit the manual production phase and shift into assembly line manufacturing with mass production, building dozens per day, the selling price of Tesla Optimus is expected to gradually drop, possibly even below $20,000. Why can they do this? Tesla may produce hundreds or thousands of units, but that represents a different mode for the company. They are leading the way and are currently the best at operating car factories. But then Starlink is able to produce mini Starlink terminals in their own factory. And if SpaceX can manufacture 5.4 million Starlink terminals per year, then Tesla will be able to produce 1 million Optimus units annually. This is incredible, because it's more than just that. They're similar, as if they're very closely related. And if Tesla can produce 500,000 cars per year, then why wouldn't they be able to produce 5 to 10 million Optimus units at a dedicated robot factory? They can, and they will.
So this year, we hopefully will be able to make about 5,000 Optimus robots. We're technically, we're aiming for enough parts to make 10,000, maybe 12,000. But since it's a totally new product with totally new, like everything is totally new, I'll say like we're succeeding if we get to half of the 10th.
In a recent live stream, Elon Musk made some bold statements and shared a few ambitious predictions for his humanoid robot project. Now, we're not saying everything he says will happen 100%, because, well, it's Elon. But some things are definitely being set in motion. Tesla plans to produce at least 5,000 Optimus robots this year, although in true Elon fashion, he casually mentioned that the number could reach up to 12,000. So things are about to get interesting. The humanoid robot race is heating up. And after closely following Tesla Optimus and the company's progress for some time, it's clear that Tesla holds a significant cost advantage over its competitors. Elon Musk even claimed that Tesla could produce Optimus for just $10,000, which is insane. On the other hand, Figure AI is also one of the more reliable companies, with a clear product development strategy. Their robots are being developed for use in factories and to perform tasks in place of humans, similar to Tesla Optimus. Back to Optimus production. As we mentioned earlier, Tesla isn't just building a product, they're pioneering an entirely new industry. This isn't like manufacturing a new phone or car. We're talking about a humanoid robot that requires absolute precision in every component, algorithm, and movement. Unlike with cars, everything from the assembly line to the AI software is being built from scratch, not copied from other existing prototypes on the market. If you've seen one of Elon's posts on X, you might remember that he confirmed Tesla will offer Optimus both for rent and for direct purchase. But rental will be the top priority. Why does he prioritize this? Instead of a one-time sale, leasing generates a steady and recurring income stream, monthly, quarterly, or annually. This allows Tesla to better predict cash flow and plan long-term finances. Many customers may not want, or be able, to pay a large upfront sum to own a brand new product. Offering rentals at a lower cost makes the product more accessible and expands the potential customer base. This could be the game-changing advantage that sets Tesla's humanoid robot apart from the rest and brings us closer than ever to the future. Additionally, Musk stated that Optimus will be produced in limited quantities in 2025, with plans to deploy over 1,000 units within Tesla's own facilities, and the potential for production for other companies starting in 2026. Optimus is being trained by the supercomputer Cortex, an AI training supercluster currently being set up on the Tesla headquarters campus in Austin, Texas, to enable what they call real-world AI. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe.